Hi and welcome to another MoTeC webinar. My name's Pete Swinney and today's subject is the reference sync setup on our M130 GP Lite ECU. Okay, so in the GP Lite we've kind of laid out the worksheets with some names referring back to our gold box ECUs to make things a little better and a little easier for the transition. So you'll see here we've got M84 names in brackets. So each group of setup parameters and tables, you'll see the old gold box name referred. So for example, engine speed pin hysteresis is the old mag levels. The engine synchronization pin hysteresis is of course the mag levels for the sync. So mag levels for the crank, mag levels for the sync. When it comes to our filter, that's actually called Debounce in an M1. So here's our crankshaft filter table and our camshaft filter table. So the numbers themselves are the same, we're just talking voltage here and time in microseconds. Whenever you're looking at an M1, if you're not sure what the number refers to in a given table, go up to the heading here and have a look. After the name of the table will be a unit. So we can see here that's the unit for microseconds. And if we go across to here for the engine speed pin, which is our crankshaft speed, the unit is voltage. So that's 0.2 volts, and that's 4 over here for 4 microseconds filtering. Okay, now on the worksheet also, of course, we have some voltages that you can see happening. So our min and max engine speed voltage, and plus the live voltage coming from each of the crank and cam sensors. And also we have our diagnostic states here, but the most useful place to observe those is these statuses down here. And if everything's all green, that means this part's all happy, it's in cycle lock, and you've got no diagnostics. Alright, so we might just flip over to, I've got an ECU here on the simulator, so we can flip over to that and have a look at it live. So we've got something here. Alright, so this is a GP Lite package in an M130, and you can see here I've got, it's quite obvious to see we've got an engine speed reference state of stall. And if I go up to here, I can see that's because we've got no engine speed and the engine's not going. So if I start the engine, which we can do with our simulator here, so we're going up and well, let's make it look like an idle, so 900 odd revs, and you can see now our engine speed reference state has gone to cycle lock, and we've got kind of normal behavior going on here. Alright, so each of these things, if you're looking for a problem, one of these statuses is probably going to be red, and then it's just a matter of clicking on it and pressing F1 to see what's going to happen. Or what it's referring to help you diagnose what's wrong. Okay, we'll flip back. Alright, so just a little bit of homework on some of the terms and going back to understanding the difference between effectively Hall sensors and magnetic sensors. So one of the terms that we come across in the M1 is the threshold. So what we're specifying here is the point at which the ECU recognizes that there's been a state change from either rise to fall, if it's a falling edge trigger that you specified, or from a low voltage to a high voltage, which would be for a rising edge trigger. So in the case of a Hall sensor, that's normally you set that threshold halfway between the high voltage, and often that's about 4 volts on a Hall sensor, and of course the low voltage is 0 volt. So an appropriate voltage to put there for the threshold would be 2 volts. If it's a magnetic sensor, then the threshold is normally, if the magnetic sensor has no bias on it, then normally the threshold is 0 volts. Because a magnetic sensor, of course, is going from a positive to a negative voltage each time the tooth passes the sensor. And for some of you who have dug in a little bit deeper on this, we need to specify an edge that we're going to choose if we're running like a mode that's not an OEM mode. So if we are in that position where we put on our own crank trigger and we're setting this up from scratch, then with a Hall sensor you can actually choose the rising or the falling edge because they are nice straight edges and they cross that threshold nice and quickly. But in the case of a magnetic sensor, depending on which way it's wired, there's only one edge that's possible to choose. So it can be wired so that the positive to negative edge is going straight through like this, or if it's wired the other way, I haven't got a capture of it here, then the negative to positive edge is the straight one. So in most cases today we don't need to worry about these things because we have an OEM mode to run the modern engine that you're probably dealing with. There's more on this in the help, of course, which is just a matter of pressing F1. Alright, now another new term in here for the M1 is called a pull-up control, and this effectively is the parameter that you are going to turn on and off to specify whether you have a Hall sensor or a magnetic sensor. So in the gold box series of ECUs, we used to actually just say Hall or magnetic was just the option that we used to specify, but here we're either turning a pull-up on to push 5 volts onto the signal to make a Hall sensor work, because a Hall sensor normally what it does is it grounds the signal from the ECU. So often you need a 5-volt pull-up to be able to ground that signal, and you get that nice square wave that we see there. With a magnetic sensor, it generates its own voltage, and actually here's the difference between the two ways of wiring a mag sensor. So if the signal looks like this, the falling edge is appropriate, and if we were to swap the two wires around on the mag sensor, the signal would then look like this, and in this case the rising edge is the one that crosses 0 volts nice and quickly. Alright, so there are those same parameters that were in the M800 and M84 and so forth. They're also in the M1, so you do need to specify on the engine speed and the synchronization, the engine speed input, which edge you're going to choose. So for the Hall sensor it can be either, and on the mag sensor it's either the falling if the signal looks like this, or the rising if it looks like that. That's a little bit of an oversimplification, but we're trying to keep this a basic webinar, so that again the help gives you a lot more detail than that. Okay, and last one now is the hysteresis, which is a new term to some of you, I'm sure. But effectively, if you can think of this in this respect, is a little bit like it's pretty much the mag sensor level. So basically it's the amount that the voltage must change before it's considered to have gone into the different state. So if we are on what we call the low voltage side here, we've got to be this much over the low voltage, this hysteresis or mag level amount above the low voltage before the computer considers that this signal is now officially high. So once it goes over this hysteresis line, the computer then considers that this signal is now high, and it's now looking for the time when it starts to go below that same hysteresis point. Now the trigger point, of course, which is the threshold, is actually on the 0 volt line. So once it goes above and then below this hysteresis, it's effectively armed, and then the actual trigger point itself will happen at 0 volts, which will be set along at this point here. Alright, so in the case of a Hall sensor, then because the voltage is a square wave and it's always the same, then you have usually a preset simple 0.2 volt hysteresis all the way across. If it's a mag sensor, as the engine speed goes higher and higher, the signal goes higher, and the odds of noise coming in and getting interference also gets higher with more load on the engine and more engine speed. So it's good practice to lift this hysteresis value up higher, and in general we want to be somewhere around 25 to 30% of the half wave, so that's from here to here, somewhere 40, even 50%, somewhere around there is where you want to set the hysteresis level. Okay. Alright, sorry, yeah, one last one, did forget, Debounce. So this was the filter. So the filter from the old gold boxes is called Debounce here, and again it's just the numbers are the same here as the gold box. We're in microseconds here, and so we have to do a calculation based on the number of teeth that are on the crank trigger or on the cam trigger, and we want to get a filter time that's not going to filter out a tooth itself, but will filter out say ignition spikes that can occur, interference that can occur in your crank and cam triggers. Alright, again F1 and on the help for each of those parameters to get some more assistance with the right numbers to put in there. Alright, so I actually just pop back and look at that live so we can go through those parameters so you can see where they are. Alright, so we are actually, sorry, at the beginning I meant to say we're in the initial setup workbook. So here's our workbooks. We're on tuning, initial setup, and we're over on ref sync page. Okay, so we're going through a list of webinars where we're covering each of these setup pages effectively so that you get an idea of what to do to set up your ECU ready for tuning. So ref sync, so here's if we've got a ref sync mode we can just choose it. So obviously this is the nice way of doing it if it's all pre-configured by MoTeC, and you'll see here there's lots of choices. Now you may have a generic ref sync mode like a multi-tooth or a crankshaft 2 missing on a 4-stroke, so that would be something like a 60-2 or a 36-1. That would be the mode you choose. In this case our configuration or our pattern is for an RB26, which suits and that's what I've got the simulator set up to now. Right, we still need to tell the ECU how many teeth are in this pattern, so that's easy enough, same as the gold boxes. The engine speed reference offset, which is our CRIP, we're going to discuss that on the next slide. Here's our engine speed pull-up, whether it's on or off, so on for Hall, off for magnetic. Here's our rising or falling edge and our threshold, and here's the two tables for the hysteresis, which is the mag levels, and the debounce, which is the filter. So all that's the setup for the crankshaft, the engine speed parameters, and this is the same setup here for the camshaft parameters. Okay, so obviously not the mode related stuff here, so just stuff to do with the actual setup of the cam trigger itself. So this one's a Hall sensor, it's rising edge trigger, and it's got a 0.8 threshold for the Hall sensor, which is actually quite low, but this mode has quite special settings. So let's just show you how you might find out what they are. If we press F1 and if we actually type Control F here, you see that text to find a particular mode, so we can type in RB26 and here it's highlighted it down. Alright, so you can see we've got specific help here that says the threshold for this particular mode should be 0.8, and I think it says somewhere down here that the sync should be identical. Offset. The reference cycle. I'm looking. Maybe it's not on this mode, but either way, press F1, find your mode, see if there's specific help, and away you go. Alright, escape. Alright, back to the presentation. Alright, so now we're going to talk about reference offset. So this is what used to be called crank index position in the gold boxes, and so now this is what the information the ECU uses to work out where top dead center compression number 1 is. Now this is almost identical to our previous generation of ECUs, bar one thing, and that is that we get the ECU synced up 360 degrees earlier, or up to 360 earlier. Now it does that by defining the crank index position. Instead of the index tooth being the first tooth that happens after the synchronization tooth, it's the first tooth that occurs before. So the offset, or the reference offset, is based on the index tooth, which is now calculated before the sync tooth. Alright, so in this, and actually in this case, the the syncing of the ECU can occur one tooth earlier. So if you're going from a gold box to a M1 and you know what the crib is in the gold box, in the M1 it's going to be one tooth of degrees earlier. So if it's got 12 teeth on the crankshaft, then it's going to be 30 degrees earlier, the reference offset itself. Alright, so that's it for multi-tooth modes. For missing tooth modes, it'll be one entire cycle earlier. So normally the index tooth is the first tooth that follows the missing tooth, and that is the missing tooth that follows the sync tooth. And it is the index tooth normally, or not normally, in the gold boxes. That index tooth, we were measuring from there to top dead center compression number 1. In the M1, it's actually done the other way. So it is the first tooth that follows the missing tooth that precedes the sync tooth. Alright, so in reality what the M1 does is it finds the missing tooth, and then the moment it sees the sync tooth, it doesn't need to wait all the way till the next missing tooth. It immediately knows, because it knows all the teeth, knows all the distances. It can start firing the moment it sees the sync tooth. So our reference offset number, or our crib number, as it was before, is now calculated it'll be 360 degrees different from any given gold box tuner. Okay, so you can see here we're measuring from the index tooth, which is the first tooth here following the missing tooth, to top dead center compression number 1. So that those crankshaft degrees is the reference offset. So it basically tells the ECU, if it wants to put timing at 30 degrees before top dead center number 1, it knows where number 1 compression is. Once it knows where number 1 compression is, knows the number of cylinders, and knows the top dead centers, it can work out where to put everything. Alright, and there's just one other minor thing to do with our reference offset, and that is if the number is smaller, if the reference offset number itself can be smaller by going negative, you can actually do that now. So whereas the previous generation ECUs you couldn't, with this one we can go backwards. So rather than going forward all that distance to this location in the cycle, we can go backwards. It's as simple as that. Now I know for most of you, you're not going to need to worry about that. Most engines are all known, their reference offsets, but this just has been a simple explanation of the kind of the different parameters and what they mean in the M1 compared to the older ECUs. Alright, last couple of things here now. So once we actually do get up and running, then we have a lot more tools in the M1 to allow us to see how things are going to do with our crank and cam signals. Alright, so the very first thing that we look at if we do have a problem, if the engine won't go, the absolute first thing we're looking at is to see if we have cycle lock. Okay, so cycle lock means the ECU has seen everything, it's all normal, and it's now turning on the injectors and the ignition. Alright, so the capture we've got here says the engine speed reference state is in stall, and there's quite a few states that this goes through before it gets to cycle lock. And so for you to see what each of those states means, all you've got to do is click on any of this. This state can be a channel or a parameter or anywhere. All you've got to do is click on it and press, you guessed it, F1. So when you do that, you get this screen here, and that'll explain what each of these states means. So you can see here, if we have a state of pattern lock, what that means is that the reference pattern, which is our engine speed pattern, is accurate, and we've got good engine speed being measured, but basically it doesn't recognize, or the sync signal's not there. So pattern lock means crankshaft all good, camshaft not able to understand. Alright, so again, just reinforcing, lots of information here. You just have to press F1. Alright, let me pop across. We'll go one more screen and then we'll go back to the live software. Alright, so this is the states, the reference state. And so because you are spending quite a lot of time looking at this, that's why we've gone into detail here. I'll just quickly go through them. Stall means no voltage at all. seen by the ECU. First edge, that's obvious, it's seen at least one edge. First period means it's seen two edges and calculated a time between them, and it seems realistic. Search means lots of edges, but it's not understanding the pattern. So if you've got the wrong ref sync mode, it's seeing lots and lots of teeth, but it's not making any sense. Pattern lock, we just covered. That's of course that it lines up and it recognizes what you've told is there. And then cycle lock means everything's happy, sync's right, the crank trigger's right, and it'll now be turning on the ignition and the injectors. Alright, let's just pop over and look at that live. Alright, so here we are. If I slow the engine right down, you can see it goes to stall. I can very slowly put some engine speed on here, and you'll see the engine speed reference state go up quickly through those things, and we'll speed it up. Now what we can actually do with the M1, if you haven't seen this, if I click over here, press T stands for telemetry, but we call it the pause function, and I can actually press F6 here, make this full screen, easy for you guys to see, and then I can double click, and this is just like our i2 software. We can just treat it like data, and we can have a look at this ECU get fired up. So there we are going, we're in stall here, so we're looking here, the purple line, stall, because I'm just moving it really slowly, went back to stall, first edge, pattern lock. I'm just creeping it up. This wouldn't be normal, but eventually it pops into cycle lock. If you really want to know how long that took, realistically the first time I probably moved it, I can press the space bar here, and this is like a measurement device and an oscilloscope, so you can check how quickly your ECU cycle locks, and in this case here that process took 0.846 seconds. See down the bottom we get the delta, or the difference between those two things. Alright, D there again, just to get rid of that. F6 to shrink that back again. And the other nice part here is not only are we paused with the lines here, we can see this all the states changing over here. Alright, and you see the sync diagnostic here is searching with pattern lock on the engine speed state. It's pattern lock, but the sync is still looking. We're still looking for the sync trigger on this particular mode, and then the moment that sees that sync trigger, we go to cycle lock, and our engine sync position diagnostic goes to OK. Alright. Alright, so if you are in a bit of trouble and you can't work it out, and sometimes it's easy to do like a scope capture or a ref sync capture. So we've got that feature in the M1, and it's called capture inputs. So to find that, you go to online and down to capture inputs, and in this case this actually captures all of our UDIG inputs. So these are universal digital inputs that you can program trigger levels on. So on an M150 we've got up to 12. On the M130 GP Lite, I can't remember, I think it's 8. Someone can probably correct me, but we can certainly capture up to 12 on an M150, and I'll show you how that's done. Alright, so here we are. You'll see here nothing seems to be moving, and that's because we're still paused. And if I show you up here how it's flashing connected, and even hover, when you hover there it says telemetry is paused. So if we click here and go T, we're away again. Alright, so we'll turn our engine off, and we're going to do a ref sync capture, or a capture input. So it's online, capture inputs, and we're going for a new capture, and we can specify how many of these UDIGs we want to capture. In this case we're just going to get 2, which is the crankshaft and camshaft. So we just want to see 2 here, and when I press OK I'm going to get that capture. So we better crank the engine. Okay, maybe it's not going, so here's the engine cranking away, and we capture. So that's doing a high-speed capture of that input. We can name that, I'll call it Seminar 1, and you see what those UDIGs are named, or those channels, and here it is. So we can, now this is also just like I2 where you can work with this data just this similar way. So this is actually, it calculates for you crankshaft degrees. Here's the teeth. This looks like a big fat red line, but we just need to zoom in on it. Alright, and you can see here, oh, I've got this configured on the simulator, not quite right. So I'll just roll out here. Okay, so the this is not configured the way it's supposed to be configured, which is as a hall sensor, but that's just my setup on the simulator. So you'll see here we have -6 volts going to 5 volts. Alright. Now in reality this is a 360 optical and it would be 0 to 5 volts or 0 to 4 volts. But because our threshold's quite low, the mode is working fine. Alright, so we can use this to see if there's any noise or interference and zoom right in. I'm just using the mouse to roll in here, and you can also see my engine speed set up on my simulator is also being configured to mag mode, where it's going negative and positive. So I'm going from -6 to +5. Alright, so just to show you what we can do, we'll actually close that, and we don't need to save it. So I'm going to change the setup of my simulator. I'm just going to switch them both to hall here. Alright, so I've just changed the simulator setup, and you can actually see over here as well the voltage just changed, the live voltages. But we'll do another capture online, capture inputs, new to, and this is a rerun, seminar 2. And now we see, scroll in with the mouse, we're going from 0 to 5. Alright, 0 to 5 there. A little bit negative, that's just, again, the simulator. We can swing any voltage we like on there. Alright, you get the idea. So we can save that and send it to the guys at MoTeC, send it to your dealer, anyone to help you work out what the mode is supposed to be, or if there's a problem with interference, or why you're having your issues. Okay, we don't need it. Okay. Alright, this is just a capture of what we just did there, so we've seen that. And that's it for this webinar. Thanks for listening in. We'll catch you on the next one.